What's poppin', dogs? Mr. Allen here with the Algebra 2 Honors Final Exam Review Study Guide, right? We're into Module 2, Topic 3 with this bad boy here. We got some rational functions. That's right. That's the one with the fractions and the polynomials within these. Oh my God, it's terrifying. But we're going to review. It's going to be dope. Okay, so we got state the domain, range, vertical, and horizontal asymptotes of the following functions. Now, we'll usually break these things down into multiple parts in a multiple choice setting, like where we'll just ask for the domain restrictions. So our domain restrictions are going to be all real numbers except that x cannot equal 8. And most people will be cool with that one, just saying, hey, x cannot equal 8. That's our domain there, right? Now, this is also going to be our vertical asymptote since it does not cancel out, right? It's left in the denominator. Our vertical asymptote is x equals 8. Now, I went down to that vertical asymptote because I want to address the horizontal asymptote prior to the range. Our horizontal asymptote here is going to be y equals 0, meaning our graph is not going to ever get to that y equals 0. It's not going to, it's just going to get really, really close to it on both sides of that graph, okay? There are situations where it will cross over and come back. Not one of these. So that will apply then to my range where y does not equal 0, right? It's just going to get infinitely closer to it. Whew, it's crazy to think about. All right, this next one here. Again, our domain, we're looking at our denominator there, so x is not going to equal -4, which is also going to be my vertical asymptote there, x equals +4. Now, we talked about our horizontal asymptote before about how is y equals 0, right? This part right here, as x gets infinitely larger, bigger, we have 1 divided by an increasingly larger number that's going to get really close to 0. And then we're going to drop down 7, right? We're going to go down 7 here with that -7 on the outside. So our horizontal asymptote is going to be y equals -7. And our range will be, hey, we got to avoid that -7, so y does not equal -7. Beautiful, fantastic, wonderful. That even went into a little bit of transformations, right? When I was saying going down 7. But hey, you know what? We're going to address that right here in number 2. So we have state the transformations performed on f of x equals 1 over x to obtain the following functions. All right, so for this first one here, we have that negative in the numerator there. Now you might be like, oh, is that in the function? Is that out? Really, we could have written this as h of x equals -1 over x minus 10 plus 2. All right, so that negative is outside of our function, so it's going to be a vertical reflection. We could also call that a reflection over, what axis would that be? If it's a vertical reflection, I'd be going over the x-axis. Okay, so different names for each. You know, if you're writing this by hand, they would accept either, but if you see it on multiple choice, probably reflection over the x-axis is what's going to be used. All right, and then we have that x minus 10, right? So if it's -10 in the denominator within the function, that's going to be a horizontal transformation, but it's going to be going to the right 10. And then that +2 on the outside is going to be up 2. Boom, there we go, man. No big deal. No big deal. All right, this next one here, that 5. Like I said before, it might be helpful to rewrite this as j of x equals, we got 5 times 1 over x minus 1, right? I can rewrite it that way. Mathematically, that is still the same thing. And now we can see that, oh, it's a vertical stretch by a factor of 5. So vertical stretch by 5, and then we're going to be going down 1. Okay, beautiful. In order to be in the function, it would really need to be in the denominator there with the x, okay? So that's where the in the function would occur for those vertical or horizontal stretch or compressions. All right, next one here. We got determine the equations of the vertical asymptotes for each function. So this first one's already factored for us, which is, oh, just so wonderful. How nice of them, right? As much as I love to factor, sometimes it's nice when it's done for me. Now, nothing cancels, so there's no removable discontinuities. We're going to be checking that out in the next one. So this time it's just both of these are x equals -5 and x equals +4 be my vertical asymptotes. This next one here, I do need to factor. So I'm going to have x, let's see here, +5 and x +6 for that denominator, right? That's what that guy's going to be. So, because it multiplies to 30, adds to 11, check. Now, nothing cancels here, so there's no removable discontinuities. If there was something that canceled, then that would not be a vertical asymptote. It's what we're left with in the denominator. So in this case, once again, it's both of them, x equals -5 and x equals -6. Those are my two vertical asymptotes. All right, beautiful. Let's change colors, man. I'm getting tired of this one. I'm going to go with, how about some green? Okay. State whether the following functions have removable discontinuities. If so, where do they occur? So for the first one, I got to factor that denominator. So I'm going to jot it down over here. We got f of x equals x plus 6 divided by, then I have x plus 6 and x minus 3. Now, does anything cancel here? Yes, the x plus 6's are going to cancel out. And I'm left with 1 over x minus 3. And I did want to write that in the simplified form because it's going to play into where does this occur. So my answer is going to be, well, it's going to be negative 6 because that's where the x would be, right? Our x plus 6 canceled, set that equal to 0, solve for x to get negative 6. But what's my y coordinate going to be? How am I going to get that? I'm going to need to plug in that negative 6 into this guy right here. So we got to plug in. So I would have, let's do a different marker for this one. We've got 1 over that negative 6 minus 3. And I don't need to put that in parentheses, but I do that to show that I'm substituting. I'm going to get 1 over negative 9. So there we go. There we have it. We've got negative 1/9. There we go. So, I mean, you could leave the negative in the denominator. Nobody really does that. It's, it's kind of weird, right? I don't know why you would do that. So usually we write it up in the numerator or out front. It wouldn't be wrong if you put it in the denominator, but I will make fun of you, okay? So, beautiful, wonderful. Let's do part B now. Shall we? We shall. Okay. So I got a factor, bro. I got a factor, right? So let's draw a line there. We got f of x equals, my numerator is just x plus 11. And then I've got, let's see here, x plus, well, what multiplies to 44 and adds 15? I'm guessing 11 and 4. And my goodness, I guessed it. I checked it. It's correct. All right. Does anything cancel here? Yes, it does. Boom, boom. All right. Now I'm left with 1 over x plus 4, and now I can use that to get my answer here, right? It's going to be negative 11, comma, and if I plug negative 11 back in, I get 1 over, you know what, I'll use a different marker here. For some reason, the eraser's not working on this thing. I don't know why. It's kind of annoying. So I've got 1 over negative 11 plus 4, so that's going to give me what? 1 over negative 7. There we go, so negative 1, oops, let me go with green here. Negative 1 over 7. Beautiful, fantastic, wonderful. And if at any time you guys find a mistake in one of these videos as we're rolling through this is pretty much just for the HHS kids. I mean, maybe other people on the internet will watch these. But if you do happen to find one, find me in the halls if you're not one of my students. And I'll hook you up with one of them Yo-Ro stickers, right? You only round once. So call me out if you got it. Shoot me an email. Find me in the halls, whatever it is. And then we can fix those mistakes as well. Because I don't want people getting confused, man. All right, next one here. So I've got, I'm going to switch to blue now. Write a rational function with a vertical asymptote of x equals negative 3 and a horizontal asymptote of y equals 5. Then sketch that function. All right, so vertical asymptote of x equals negative 3. I'm going to have x plus 3 in my denominator. Right, and there's a couple ways you can write this one out, but I'll go ahead and do a y equals. We're going to have a fraction here. I got x plus 3 in my denominator. I don't like that 3. That's a little better. And then I can just throw a 1 up here. And I can shift this bad boy up 5 for my horizontal asymptote. Right? You could have also done like a 5x in the numerator. So another option would be y equals 5x over x plus 3. That would do it too, right? The degrees are the same, both x and x. So it'd be my coefficients of 5 over 1, so y equals 5. So that would also work. Either one of these are cool. There's actually a number of them. You could do 5 times like x plus 1, 5 times x plus 7, whatever. So there's a lot of different things we can do here. So I'll just go ahead and graph that first one there. We're going to have a vertical asymptote of negative 3. You know what? Let me bring up my ruler. I'm feeling spicy here, right? I want to make it nice and neat. Oh, wonderful, fantastic. So we got negative 3 there. X equals negative 3. Lovely. I kind of wanted to have it in pink for the asymptotes there. And there's our horizontal one at y equals 5. Beautiful. And now it doesn't really require us to have any points here. We could. I could throw in 0 for x, and I know I'm going to have like, what, 1/3, comma 5 for my top one there. So I would just have something right around there. Okay, so you know what? Let me go with a different color for my actual graph here. So we'll go green for the graph. Why aren't you making green? Oh, come on. And our other one, we're going to have something like that. Cool. The other graph would have looked a little bit different, but, you know, pretty close. All right, so anyways, yeah, a little bit different graph for this one. So I did this graph right here. Okay? Let's say this. Let's go with option 2, not graphed. There we go, for anyone just looking at the key, right, and not watching the dope vids. All right, next one here, we got consider the functions f of x equals 1 over x and h of x equals 1 over x minus 2 plus 5. So sketch h of x, okay, the one that's got stuff going on, and state the domain and range of h of x. So let's see here. I think it might be helpful to write down our vertical and horizontal asymptotes. So I'll do part C first. I like to do that. So we got vertical asymptote of x equals positive 2, right? I get that from my denominator. And I've got a horizontal asymptote of y equals 5. Beautiful, because it shifts up 5. That's a crazy looking 5 there, man. All right, there we go. So let's go ahead and graph these. So I got, I'll go with the 5 first since I'm almost right there. Y equals 5. Whee! And then I've got x equals positive 2. Let's get that vertical. Oh, my goodness. I almost had... There we go. All right, x equals 2. And now, let's see here. What else do we need? Well, we could plug in a point, right? I could plug in, like, let's just say if I plugged in 3, right, I'd get 1 over 1, which is 1, plus 5 is 6. So 3 comma 6. There's a point right there on that graph. I guess I'm doing this one all in pink. Last time it gave me trouble trying to switch. There we go. And I can even plug in, say, like, I can plug in 0, right? 0 would give me negative 1/2. Plus 5 is 4.5, so we'll go right there. Not necessary unless we ask you for points, right? But there we go. Wonderful. Our domain. Well, our domain is going to be x cannot equal what? It'd be 2. And my range is going to be y cannot equal that horizontal asymptote value of 5. Awesome sauce. That's dope. Super dope. All right. Man, we are just cruising through this module. I need a quick water break. All right, these problems are they're kind of beast, okay? So we're gonna look at our asymptotes first, okay? So kind of like one of the other ones we did, but now we're just looking at it from a graph perspective. So I'm gonna give myself a nice big old f of x, right, equals, I'm gonna give myself a fraction to work with. Now my vertical asymptote looks like x equals 2. So I know I'm gonna have an x minus 2 in my denominator, right? Cool. My horizontal asymptote is y equals 1. What should I do with that? Well, we do have a couple options here. I could go the route of just adding 1 on the outside, and I'm actually going to erase this obnoxiously long fraction line because I'm going to do a little different than I was thinking initially. We can have a plus 1 here, and let's do this. I'm going to just throw a 1 up in the numerator for now, right? Okay, so right now as it sits, I have a vertical asymptote of x equals 2, right? So that's cool. I have a horizontal asymptote of y equals 1 because this part right here, right, as I get larger and larger and larger x values, it's 1 over something really freaking big, which is going to then tend to 0, right? Because a small number divided by an increasingly larger number gets smaller and smaller, right? Plus 1 gives us 1 for my horizontal asymptote. So that's all good. But what about those points? Well, if I plug in 0 for x, I should get, it looks like, 0.5 for y. So let's see if we get that, right? If I plug in 0 for x, 0 goes in here. I'm going to have 1 over, and I have, actually, you know what? Let me do it off to the side here. I'm going to have 1 divided by 0 minus 2 plus 1. That's negative 1/2 plus 1. That equals positive 1/2. Did I get the output that I wanted when plugging in 0 for x? Yes. All right. Beautiful. That's wonderfully fantastic and awesome. So I think this one's all set to go here on that. We tested a point. That's great. That's fantastic and wonderful. Now, the other option, you could do this all in like a single fraction. So we could have, let's call it, still f of x. It's still going to be the same. It's an equivalent function here, or, well, it would produce that same graph based on these specs that we have. So I'm going to, again, have the x minus 2 in my denominator. But in my numerator, I'm going to throw an x up here for now, and then we'll see what we need to do with that, okay? So my x-intercept is actually very easy to deal with in this form. So I can actually do x minus 1 in my numerator, and that will allow me to get that point right there. Let me show you what I mean. So if I set this whole thing equal to 0, right, if I set it all equal to 0, the only way I can get this fraction to equal 0 is if my numerator is 0. So if I say 0 equals x minus 1, I'm going to get 1 on my left-hand side there and x. So x would equal 1. So I'd have the ordered pair 1, 0, which is what I want, right? And since my degrees are the same here, since I have a degree of 1 and 1 right there, I would look at my coefficients of 1 and 1. So y equals 1 would be my horizontal asymptote. All 3 specs here then check out, so that is wonderful. We are good to go on this bad boy. So option 2 there, if you so choose. This one's fine as well for those of you that are like, bro, what's up with those parentheses and not parentheses? I'm gonna go that route. Okay, it was a little weird. You know, I'm gonna pop those off too. I don't want them. All right, wonderful, fantastic. I'm talking too much. Let's continue. Consider the rational function x minus 2 over x squared plus 2x minus 8. Factor and list any domain restrictions. I love factoring. You couldn't ask a better time for me to factor here. I'm so excited for it. All right, so you have x minus 2, and then we have what multiplies the negative 8 adds to 2. That's going to be x plus 4 and x minus 2. All right, so domain restrictions. Domain here, x cannot equal what? Well, it's everything in that denominator there, because that's going to make my denominator 0. Can't divide by 0. It'd be undefined. That's no bueno. So I'm going to have negative 4 and positive 2. So there's my domain restrictions, right? Write the equation of the horizontal and vertical asymptotes, if any. So my vertical asymptote, will be x equals, well, check this out. That's going to cancel. So now I'm going to have just x equals negative 4. Okay, x equals negative 4 there for my vertical. My horizontal, well, since the original degree in the numerator is smaller than the denominator, then I'm going to have y equals 0 for my horizontal. Now come the holes here. So I know the holes, or hole just one, we're going to have 2 comma something, but we got to find that something. So now I have this simplified form of 1 over x plus 4. So if I plug in 2, I'd have 1 over 2. I like to throw it in parentheses when I'm doing substitution. Plus 4, that's 1 over 6. So we're going to get 1/6 for my y coordinate there of that hole. All right. And then we got to sketch this graph. So I like to throw down my my asymptotes, right? I already got the vertical ready to rock and roll, so we'll throw that in there. We got negative 4. 1, 2, woo. And then I got my horizontal of y equals 0. There it is. Oh, that was pretty darn close there. There we go. Awesome. All right, and then I've got a hole. I'll do this in a different color here. We'll go green now. 2, 1, 6. So 2, 1, 6. So I'll just make that really close there. Anything else that we have here? I mean, we can go with a y-intercept. It's going to be 1/4. If I plug in 0, I can just look at this guy, these two guys right there. Negative 2 over negative 8 is positive 1/4. So 0, 1/4. So we're like right there. That's really all we're going to ask you for. Any key points there if we're going to have you graph some. That got away from me there. Let's get that a little closer. There it is. Here, and then we're going to, whoop, beautiful. And then this one over here, we can just kind of mirror it. All right. If you want to pick another point, that's cool, but you can always just kind of, it's going to be another one right there. All right. Things do get a little crazier in future rational functions, but for now, I mean, we're keeping it a little bit, how you say, low key, right? That's how the kids say it, right? We're keeping it, low key, down low, not the hush hush, because that'd be, we're not talking about it, because we are talking about it, right? But it's no big deal. But I mean, these rational functions can get kind of sus, so watch out for that in the pre-calc honors world. All right, I'm done talking. That's it for this one. Module 2, topic 3, solving rational equations review is the next one. Oh, it's gonna be awesome.